This discussion is an overview of the WCRL cluster ownCloud deployment. The motivation for deploying ownCloud in the WCRL cluster is to synchronize files between personal devices and cluster home directories. Commonly considered files are the PCS job and task queues and program code created by researchers. The current PCS workflow involves several distinct steps and specialized tools to move files between devices in the cluster. ownCloud has the potential to simplify this flow. Before we proceed specifically to ownCloud, let's briefly review cloud storage concepts. For our purposes, we will define cloud storage as automatic file synchronization between one or more clients to and from a server over TCP/IP networks. Note that this definition includes the internet, which is a major difference in design versus common file access protocols such as network file system and server message block. Commonly cited limitations with those protocols are security when used over the internet. Well-known implementations of cloud storage are Dropbox, OneDrive, Google Drive, and ownCloud. ownCloud is a self-hosted cloud storage service providing clients access to files through the official ownCloud client, a web interface, and also the WebDAV protocol. WebDAV is a standardized extension to the HTTP protocol implementing read and write operations for file storage. Utilizing HTTP between the ownCloud server and clients inherits all the advantages of utilizing a well-known protocol. These advantages include, for example, 1. Many existing infrastructures contain web servers already, and since the ownCloud server is implemented as a web app using PHP, the ownCloud server can utilize the web servers which are already deployed within infrastructures. The security considerations for the HTTP protocol are widely understood. ownCloud inherits the security mechanisms already in place on a secured HTTP server. Most firewalls permit HTTP traffic by default, removing the need for additional network configuration. A bit of history about ownCloud. ownCloud originated with a keynote at the KDE Developers Conference by developer Frank Karliczek. In this keynote, the motivation for a self-hosted open source cloud storage solution was presented. 2 years later, the company ownCloud Inc. was founded, producing 2 variants of ownCloud, a freely available distribution available at owncloud.org and a subscription-based enterprise edition providing additional services available at owncloud.com. According to ownCloud's official business statement, the business model of ownCloud is very similar to other successful open source companies, offering services and support around ownCloud for the enterprise. The company is dedicated to working entirely in the open, accelerating development in the areas of its customers' needs while enabling a completely open development process where everyone can contribute. Moving specifically to the WCRL cluster ownCloud deployment, the deployment on the head node is implemented by a Debian package. The functionality provided by this package are the ownCloud server itself, a Linux-based WebDAV client which enables mounting ownCloud shares within the Linux file system, a script executed by users to enable an ownCloud share on the head node under the user's home directory, automatic mounting of user shares during head node boot. Note that ownCloud requires a SQL database. This requirement is satisfied by the WCRL MySQL deployment. ownCloud provides a web-based administrative interface which allows configuration of, amongst other things, cluster users having access to their own cloud shares, user storage quotas, and optional ownCloud features such as server-side data encryption. In this window, we see the ownCloud administrative interface for the WCRL cluster deployment. The most notable features for the WCRL deployment are under the OC Admin tab and the User and Admin buttons. Accessing the Admin button first. The WCRL ownCloud deployment uses an LDAP directory to read its user accounting information. This LDAP directory is stored on the head node. Under this server tab, we can configure details of the LDAP directory. Since it's hosted on the head node itself, the network address of the directory is given as localhost, and the base distinguished name containing the user accounts is specified in this line. Under the user filter tab, we specify exactly which cluster users have permission to access ownCloud shares, and the criteria applied in the WCRL deployment is that a user must be a member of the POSIX group ownCloud users. To see a list of users who have access to ownCloud, we go to the OCAdmin dropdown under Users, and here we see a list of all active cluster users who have ownCloud shares. Under this tab, we can also configure disk quotas if desired. Now we will discuss the process for enabling a specific user to access an ownCloud share. In the first step, the user contacts the WCRL administrator and requests ownCloud service. On the head node, the administrator adds the user to the POSIX group ownCloud users by executing the given command. In step 3, the user configures their home directory share by logging into the cluster personally via SSH and executing the given command. This command prompts the user for their WCRL cluster password. After execution, the user will have a new directory under their home, which is OC. This is their share directory where all of their ownCloud shared files will be located. In the fourth step, the user configures ownCloud on their personal machine using the official ownCloud client appropriate for their platform. When prompted, the user gives WCRL specific information to the client. A note about security. ownCloud is served via the application layer protocol HTTP. Transport layer security is a standardized protocol for performing end-to-end encryption and peer identification for application layer services via a public key infrastructure. End-to-end encryption is achieved by encapsulating HTTP within TLS. The resulting encapsulated protocol is denoted as secure HTTP. In order to enable HTTPS on the WCRL cluster, head node requires acquiring an X509 certificate, which is also commonly known as an SSL certificate, from a certificate authority. Certificate authorities verify the identity of an organization for a fee, issue a certificate, and verify the head node's identity to clients which connect via HTTPS. Now we will show some examples of using ownCloud. In the first example, we will create a file on a personal device and observe synchronization with the user's cluster ownCloud share. The client we are using for this example is a virtual machine executing Ubuntu Trusty with an account having name test user. Note that in the test user's home directory we have the ownCloud directory OC, and in this directory there are two files, hello and hi. We'll now log into the cluster and show these files in the OC directory on the cluster. Note that in the OC directory, we have the same files on the cluster as are on the user's local directory. Now, let's create a new file on the local directory and observe its synchronization with the cluster. So I'm going to call this file A. See the new file. and we see that it hasn't been synchronized with the cluster. In the next example, we will demonstrate connecting to the ownCloud share on the cluster using a file manager via the WebDAV protocol directly. In the example, we will use the file manager PCManFM. Most file managers within modern operating systems have the capability to connect to WebDAV shares natively. For this particular client, we choose Go, Connect to Server, provide the details of the WCRL cluster ownCloud deployment, a specific path, which is /ownCloud/remote.php/webdav, and our login name, which is test user. Click OK, and we can see the contents of the ownCloud directory on the cluster. We could even create a new folder and observe its synchronization with our local directory. We'll wait a moment for it to synchronize. The folder is synchronized, and our demonstration of WebDAV via a operating system native file browser is complete. Thanks for watching the demonstration.